Okay. All right. Thanks, everybody. I appreciate your time, spending next 15, 20 minutes talking a little bit about what a multi-tenancy can deliver in the world of sort of a technology adoption. So I want to spend a couple of minutes before I start diving into the topic, talking a little bit about what's the domain and what do we do as a company, so that you can contextualize what we're going to talk about a bit more as we move forward. So Sumo Logic is a machine data analytics service. That's a mouthful. And so let's talk about what machine data is. Machine data is generated by all of your applications infrastructure, IT infrastructure. It's generated by application components, databases, web servers, things like that. It's generated by your security tooling, your IDSs, IPSs, your network gear. It's generated by your tooling, and ultimately it's generated by your application. So all of this data is an artifact of running software on top of IT infrastructure. And the type of data that comes out of this infrastructure really takes three forms. The first form is log data. Log data can come from any level of this layer of this componentry, and it can tell you things like, there are exceptions being generated by your code. It can tell you errors that it's seeing. It can tell you transactions that are being executed. It can tell you, things like user actions and all of this stuff that happens inside of your application. The second part is metric data. So metric data can tell you things like how much CPU or I/O or memory is your server or host or container using. It can tell you things like, hey, what's the insert latency into a database? Like, how fast am I writing records to a database? Or things that are specific to your applications, things like transaction statistics. How long did it take to process a payment transaction that needed to get inserted into a payment system, right? So anything that's numerical that tells you stuff about performance or consumption is a metric, right? And the third one is events. And events can actually be pretty broad and varied, but events could be things like SLA violations. They could be like an event of specific code deployment. Okay, we pushed code to production at this time. It means that version X+1 is now running in production, right? Things like security incidents. We're getting DDoS. We're getting hit by malicious actors. All of these things are generated by systems and infrastructure and can tell you and help you manage your workloads, right? And what does that mean? So that means for development, operations, SRE teams, it can help you, by having this data and performing analysis on it, can help you measure availability, optimize performance, perform root cause analysis. When you have an outage of your application in AWS or elsewhere, you can then perform root cause analysis to figure out what caused the outage, bring the system back quickly up, and basically not experience that incident again. If you're in security or compliance, it can help you understand your compliance, prove your compliance to your auditors. It can help you do security alerting. It can help you do incident response and things like that, right? So it helps you essentially manage the security of your application and infrastructure. And then it can also help you with business analytics. Like these modern applications, coming, serving customers, generating revenue, log metric data from these applications can tell you a lot about your business, right? You can actually tell you about how are users behaving in your application. What products are they buying? What are they looking? How well is your application doing for your users? It can tell you about business KPIs, revenue, number of clicks, all of that stuff that's important as you monitor how your business is doing in digital, right? So this is what machine data analytics service can provide, right? And this is what we do. And so what I want to transition into now is talk a little bit about how we use this. This problem of machine data analytics and operational security visibility is broad, and it's across all industries and across all sizes of companies, right? And so our companies, we tend to serve enterprise-class companies, large, mid-sized companies that are running in cloud and on-premise. But all of these companies ultimately have one thing in common, is they run mission-critical software applications that serve their customers, generate revenue of one type or another, right? And all of these customers here on the slide are a subset of customers that use Sumo Logic service to deliver these types of capabilities to their enterprise, okay? So let's talk a little bit about this global intelligence and global benchmarks, which is the topic of today. So what is what are global benchmarks? What is global intelligence? So we run a massive multi-tenant cloud service. All of our customers run on one environment. We don't have individual deployments for customers. We run one big SaaS service, and every single customer runs on it, right? And so as we run our service, we compute benchmarks that help our customers create better outcomes for their workloads. And benchmarks can be very, very simple and can be very complex. Let's start at sort of the simple level of benchmarks. A benchmark could be, what's the rate of database class adoption for AWS workloads, right? How many people are using SQL versus NoSQL? How many people are using MongoDB versus Cassandra versus Oracle versus MySQL, right? And that can be very helpful if you know that information as you're adopting cloud services or moving to the cloud or re-architecting your application, as you're selecting technologies to be able to help you in this sort of early part of software development lifecycle to basically be able to pick the component that might be best suited for your microservice for a specific workload that you're trying to build, right? When you move down in the software development lifecycle, you might be making different types of decisions, like what type of architecture am I going to choose? How am I going to run this infrastructure? So let's say that you've selected a NoSQL database, maybe a document database like MongoDB, right? So the challenge in today's environment, global environment, is that there's a massive lack of skills inside technology and non-technology companies as they are trying to build this new type of architectures and new types of environments like AWS and others. And so how do you decide, when you've picked a new component, how to run it, right? So a benchmark such as, where do people run things like a MongoDB in AWS? Are they choosing memory class optimized instances? Or are they choosing compute optimized instances? Do you know the answer to that? We didn't know the answer to that, but the community does. People are running these instances, they're running them on specific types of instances, and they're optimizing their workload, and they are, through that, sending us signals about what is the right way to run a MongoDB class database in the cloud, right? And so as you go through your implementation and architecture, a benchmark around, you should choose a compute-optimized, large or extra-large instance to run a typical MongoDB cluster is potentially very helpful piece of information. As you move down into the next stage of the development lifecycle or adoption lifecycle, you might be inside the load testing bucket. You've now architected your application, you've picked your components, you're now running load tests, and you're trying to figure out, are you getting the right performance, right cost from this cluster that you built? How do you know whether you're running best of breed, best in class, whether you're in the middle of the pack, or you're really not getting the right performance out of your infrastructure systems? If I take that MongoDB instance as an example, going down further, would it be helpful to you if we could tell you that global community gets, 97 millisecond insert latency into MongoDB for average document size, or they're getting 63% CPU utilization on this type of instance class when they're running MongoDB on top of it, right? If you compare what you're getting in your performance testing to what the community is getting, you can get a signal about where you might want to spend your efforts in optimizing to get either better performance, better availability, better SLAs, or better cost picture for your application, right? This is very hard to get when you run in a silo, in a sort of single tenant way, and you're trying to learn everything yourself. And then when you move from load testing into production, what could information about how your infrastructure is running, behaving, performing, tell you about ability to improve your monitoring, improve your availability, your performance? So now you're no longer in your pre-production stage. Would you want to know that your production instance is drifting in utilization, or you're getting, let's take a different example. Let's take a security example, and we're going to go deeper on the security example. Would you want to know that your threats that you're seeing in your environment are different than the threats of other AWS customers? Would that send you a signal that maybe you have misconfiguration in your environment and something is trying to exploit it, right? So when you're running on your own, in your own silo, it's very hard to know that. You might have that information, but you might not know whether that's good, bad, or ugly, right? So this is what benchmarks are. And the benchmarks are computed by basically computing, boiling down, information across thousands and thousands of community members and users and infrastructure components and tens of thousands of instances in a single multi-tenant environment, and then providing that information to you to serve you better as you adopt technologies through the lifecycle of technology adoption. So that's what we mean by global intelligence and global insights. So let me ask you a couple of questions. We're going to start simple. How many of you think that you use 10 or fewer AWS services inside your production accounts? If you raise your hand if you think you use less than 10. Raise your hand? No? How about between 10 and 20? Nobody? How about between 20 and 30? Okay? All right, so here are the stats. A median enterprise uses 19 AWS services in production. 90th percentile use fewer than 30, so you guys might be an anomaly in here. And we, Sumo Logic, we have been in AWS for 8.5 years. We only run in AWS. We're pretty mature users of it. We actually use 31, right? But an average or a median number of customers does not use more than 20, which is interesting. I have another question. Raise your hand if you think that EC2 is a top 10 adopted AWS service. EC2, okay? Okay, the rest of you guys don't think EC2 is a top 10 adopted AWS service? It's hard to believe. What about S3? Raise your hand if you think S3 is a top 10. Okay? How about Lambda? Lambda, 1? Okay. Check this out. EC2, 94% of customers. Makes sense, right? What do you buy in the cloud? You buy compute, storage, and maybe network and database. S3, 50% of users. So S3, believe it or not, even though it's one of the biggest services in AWS, is not a top 5 AWS service. In fact, it's quite a ways down. And Lambda is top 5. It's amazing, right? When you have the information, what you can learn from this information. So this is just kind of on the how do I adopt and what do I adopt and what are the associated services, and there's a lot more information we could talk about this. But I want to spend a little bit of time talking about a specific example and an operational example. We're going to focus on Amazon GuardDuty. How many of you are familiar with GuardDuty? Yeah? Some of you are not? Okay. So next slide would not be wasted. So Amazon GuardDuty is a service. It's a security service. It's pretty interesting. What it does, it scans your environment, right? It continuously scans your environment, your AWS account, hits your APIs, hits your configuration, and tells you when it detects that you have threats that are actively executing in your environment, right? And so it's pretty useful because if you're not monitoring all these aspects of your AWS account, if you turn this on, it will tell you, it will in real time send you information about what it is detecting about your security posture right then, right? And if you consume that information, you can then react and maybe go and fix things and hopefully not get hacked, right? So it's a useful service. We are partners with AWS on this service, so we have an integration. But the question now is, what could we do that delivers more value on top of that service? So what we did is let me kind of walk you through what it actually does. So GuardDuty first communicates to you and says, okay, here's the threat categories that we are going to monitor, okay? They're going to monitor things like, okay, unauthorized access. Is there unauthorized access happening in your environment? Is there reconnaissance? Are there Trojans that are being active? Is there cryptocurrency mining that's happening in your account, right? They do this by basically detecting specific conditions behind the APIs or infrastructure that will tell them, okay, we think that this thing here is communicating to cryptocurrency pools somewhere out on the internet that's a known pool, and we can tell you that your EC2 instance is doing cryptocurrency mining right now. And unless you're in cryptocurrency mining business, somebody's sucking up your CPUs, and they've owned your account, and they're using your account to make money, right? So that's the kind of thing that GuardDuty detects, right? What they also do is after you look at, on a global level, what is the picture of the threats that are active across thousands of GuardDuty accounts, right? So unauthorized access and reconnaissance seem to be the most prevalent set of threats. So I'll ask you, what do you think you could do with this information? If you had the GuardDuty emitting your own threats to you, and you knew what happens across the globe, what is the kind of expected and normal information, would this be useful? And if you found that stealth or, I don't know, backdoor access for you is 90%, and for the global community is 6%, maybe that's something that tells you something about your posture and about something that you need to do to secure yourself better, right? So let's go one step deeper. So they also give you the severity, right? So what does severity mean? So if severity is low, it means that GuardDuty thinks that you have defended against that threat. So something's tried to do something, but you're pretty safe. If severity is high, there's a pretty high level of confidence that there's something actually occurring and that it's been successful in your account. Okay, so that's pretty bad. If severity is medium, they are not sure. So I don't really like the fact that that's the distribution that you get, right? A third of it is low, and then 2/3 of it is we don't know, right? Nevertheless, it's a piece of information that can be useful, right? And then, only a little bit is determined as bad and active. And we want to see this as small as possible, but that's that. So let's look at this over time. How does this look as you look at this over time? Because this was a picture, a point in time, and what I want to know, if I'm a customer and I'm comparing myself to this picture, is this different every 15 minutes? Because maybe 15 minutes ago something else was happening and it looked entirely different. And when we unpack that data into this global benchmark, it looks pretty consistent, right? It does not really change, but fluctuate by a few percentage points over time of what threat posture is. And this is pretty useful, because now you know that the picture of the global threat posture and severity posture across the AWS accounts in the wild is pretty consistent. So what that can help you do is, if you know that and you can compare where you are, you can understand how the threat posture in your environment is changing, and again, telling you something about what your actions and activities might want to be to secure yourself, okay? And so let's take that other picture, the picture from over here, into the time view. And so if I look at the threats over time to see whether the threats are changing over time, again, we get the same picture. Remember, this was unauthorized access and recon, and those are about 2/3, and they're pretty consistent. And this is a 7-day set of data that I picked. But so that can be exciting, and it can also be a little bit kind of discouraging, because if nothing's changing, how do I use this information? So let's remove a lot of hay and maybe try to leave a few needles and just understand how do those needles look. So if I take this data and I strip away everything but severe, look, high severity events, and if I also strip away everything that is not rare, and because we see thousands of accounts, we actually know what's rare, right? We can find those rare events that occur very infrequently. And when you do that, this is what you get, okay? Now I've zoomed in. This is the same 7-day picture, and because it got washed out in this big, massive sea of data, what you now see is that on day 2, there was something that was different. For high severity event, of number of events that compose less than 10% of the data, okay? So if you think about what this is, what we've done now is we've zoomed in on maybe a handful of customers in this large pool of thousands of accounts that have these conditions satisfied. And what that is, when you look deeper, that is a cryptocurrency Bitcoin mining tool running on those instances, and it is successfully communicating with Bitcoin mining pools. And that means that somebody, some set of customers in this global picture have been owned, unless they're Bitcoin mining companies, which I doubt, right? And something is happening that's severe. And so think about what would that mean if this type of information could be emitted to you automatically. If I could tell you, based on what I know about across the globe and based on what I know what's happening to you, you are currently experiencing a highly, highly elevated set of events that you probably want to know about, right? And you can think about this across every single type of use case. You can apply this to, say, relational database service. And you can say, what is my insert latency? Am I experiencing problems in my production environment? If I can tell you that all of a sudden your insert latency has two standard deviations off of what we see in the wild, that information can actually help you avoid all kinds of problems and downtime and things, right? Which you might not have monitored for, right? Some people might, but many don't, right? And so this gives you kind of this global context about how you run your infrastructure and what you're getting versus how is everybody else leveraging the infrastructure and what they're getting out of it, right? And so when you turn this into something that might be useful, I'll show you a screenshot of our product. So let's look at that for a second. Okay, so this is a dashboard that uses this GuardDuty information. It's something that's going to go into beta in next week or two, but it's hard to read here. I'll walk you through it. So this row here is for one of our accounts, and from those 10 threat categories that we saw on the first screen here, what this account experienced is Trojan, backdoor, and recon, and the red line is quote-unquote normal. So what this is telling me that this account is experiencing a dramatically higher Trojan activity than normal accounts in AWS, right? And almost 2x backdoor access. And these are probably related because you probably need the backdoor to get your Trojans in, and then you got Trojans, right? So this is a interesting view. Like down here, we'll talk about these. So basically, this is you and this is the benchmark, right? And if I could tell you that in real time, it could be very useful for a security team to understand that in context, right? Then we tried to do something slightly different, and we said, okay, let's look at the individual threats, not just the categories, but what threats are occurring inside this account. And so in here, again, I'll try to read this for you. This threat is recon threat, and we saw that the recons are higher up there. This is IAM user resource permissions, and that's a medium severity threat, right? But down here is backdoor EC2 command and control activity. Okay, this is a pretty bad. If you're a security professional and you see this somewhere, anywhere in your environment, it's bad. It means that something is running and communicating with known command and control servers out on the internet and over the right protocol, yada, 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 right? Basically, somebody's doing some malicious stuff. They're controlling your infrastructure, right? And so this benchmark system scanned the environment, compared it to what it sees in the wild, and it basically detected that you have a higher set of incidents on command and control activities. And then the third one down here, let's try another thing with this. We said, okay, let's forget about everything else and let's only look for rare events. And so down here, we stripped everything that's not rare out, and there are 1, 2, 3 rare events. This is the one that we saw already up there, so there is an overlap because that happened to be a rare event as well. But there are others, right? EC2 drop points and DNS, and then resource permissions. And so all of these things happen very infrequently, and this will detect those needles in a haystack. And it'll say, okay, for a rare event that I know that it's rare based on the global environment, do I find any of those in your environment, right? Pretty hard to do if you don't know what to look for, but that's basically what global intelligence makes sense. Does that make sense? Any questions? We're in what booth? We're in booth 840. Lots of people over there can help answer some questions about this or anything else. All right? Thank you.
Thank you, Bruno.